Hello, welcome back. Today, we want to talk about applications of normal distributions. So in a previous video, we talked about looked at the standard normal distribution and basically how we can use it to calculate probabilities. Now we're going to use today, look at some applications where we use the standard normal distribution that help us then answer questions. So our goals are, this is from the past, building inverted data from a normal distribution to a z-score, and also be able to calculate probabilities from a standard normal distribution for application problems using tables or Microsoft Excel. And for today, we'll use Excel. So just a review, z-score. So recall, for any data value x from a normal distribution, the population mean mu and standard deviation sigma, so the way to find the z-score is this. Remember what the z-score does is it basically what's called the standard normal distribution, is it standardizes it where basically your mean will now be at 0, and basically if you're one standard deviation above the mean, then your z-score is 1, and if you're, let's say, one standard deviation below the mean, your z-score is -1, so forth. So basically, to find probabilities for a normal distribution, what we're going to do is convert our data to a z-score. Then we use a standard normal distribution table or software like Excel to calculate the area under the what's called the probability density curve. And also, if we use the tables around the z-scores of two tables for the standard normal distribution table, we use the tables because that's what they use. Let's look at an example over here on the right. See what this says. It says the height of adult men in the U.S. is approximately normally distributed, with an average height of 68.6 inches and the standard deviation about 2.8 inches. Use this information to answer the following questions. So first part, or part number 1, is basically to use this information to kind of draw a picture and kind of get a better idea of what this looks like. So let's take a look. So what our mu is 68.6 inches, and our standard deviation sigma is 2.8 inches. So 68, so remember 6 feet tall is 60 inches. So 68 is about 5 feet 8 inches, or almost 5 feet 9 inches tall is the average height of US men. Now, if we look at this, first off, just do the normal distribution based on this. So remember, it's going to be a bell-shaped curve. Let's see if I do a little bit better job than that. Okay, that's fair. Here in the middle is 68.6. Okay, that's our mean. Now it says draw a normal distribution with a mean and first two standard deviations above and below the mean. So if we go one standard deviation above the mean, add 2.8 to 68.6, we get 71.4. And then another standard deviation above that, two standard deviations above would be 74.2. Okay, so 71.4 is almost I said this wrong a minute ago. So 60 inches is about 5 feet tall. So 71, that's almost 6 feet tall. And then this would be about 6 feet 2 inches, two standard deviations above the mean. We go a standard deviation below the mean, so subtract 2.8 from this, we'll have 65.8. And then another standard deviation below, that's going to be 63. Okay, so once again, this is our mu. This is mu plus sigma. This is mu plus 2 sigma, so two standard deviations above. Mu plus 2 sigma. And then here, one standard deviation below is mu minus sigma. And then this, of course, then is mu minus 2 sigma. Okay, so if you recall from past discussions, we said that anything beyond two standard deviations from the mean, either above or below, is unusual. So if you're basically over 6 feet 2 inches tall, or if you're under 5'3" for an adult man, that's unusual. Okay, that's the very untypical. Now, this is what our distribution, essentially some characteristics of it, looks like in the inches and the values we're given. Now, let's use this to answer questions. What's the probability that a man selected at random will be shorter than 60 inches, 5 feet tall? Okay. So the probability of X is less than 60. What I want to do then is convert this to a z-score. That's our first goal. Find the z that goes with this. So z then is going to be 60 minus our mean, which is 68.6, divided by our standard deviation, which is 2.8. Remember, the z-score is a unitless value. And we'll also round this to 2 decimal places. So 60 minus 68.6 divided by 2.8. And we'll just round this to 2 decimal places. And so that is going to be negative 3.07. 2 decimal places. Now, already, hopefully, we can tell this is beyond, because after all, we said that 60 inches is right over here. Okay, so let's actually draw a couple charts here. So we're starting off with this. So here's our mean of 68.6, and then 60, or 5 feet tall, is way over here. So the question was, it's probably to be shorter than 60 inches. So essentially, we want to find this area under the curve over here. Now, in terms of a z-score or a z distribution, essentially going to be the same shape, and that's going to look like this. So here's 0, and here is negative 3.07. Okay, so even though I'm not drawing it the same, it should be exactly the same shape. We just convert it to a z-score, to a z distribution. Okay, and want to find this value. Okay, want to find that probability. So if you saw the last video I posted, I'll write that better, we learned how to do this. And so let's actually need to more space. So give me just a moment. Let me move this down. Okay. So what we can say then is that the probability that x of original distribution is less than 60 is the same as the probability that z is less than negative 3.07. Because once again, these are the same distribution, it's just kind of scaled differently. This is the same area here and here. So if we answer this, it will give us the answer to this. Okay. Now, in Excel, we use Microsoft Excel. Remember how we do this? This is going to be right as normal, normal dot s for the standard distribution dot dist. Then we type in this value, negative 3.07, and also the word true. This means we want the cumulative distribution. So let's do that. So let's open up Excel and have Excel open. So equal, just start to type that in, NORM, and make sure you pick the right one. For the standard normal distribution is right here, norm.s.dist. Double click on that. So it says we need 2 things entered, once again, as we said. The z-score, which is negative 3.07, and then we're going to write the word true because it says cumulative. We want the cumulative distribution. That means everything to the left, which is what we want. We type that in. It's a very small number, which you expect it to be. Okay, we expect that the fraction of the U.S. men, adult men who are less than 5 feet tall, is small, or probably finding one that's small and random. And so the value is 0.00107. And so in percent, that's going to be 0.107%. So about a tenth of 1% of adult men we expect to find who are less than 5 feet tall. Okay. All right, let's do another one. And once again, let me go ahead and put some more space here. Probably going to need more. Okay. So a similar question. What percentage of men are taller than 78 inches or 6 feet 6 inches tall? It's going to expect this to be a fairly small number as well, but we'll see. So I want to find the probability that x is greater than 78. So just as we did the last one, I want to convert that to a z-score. Okay. So then z is going to be 78 minus 68.6 divided by 2.8. Calculate that. And we expect it's probably going to be over standard deviation over, or z-score over 2, but we'll see. So 78 minus 68.6 divided by 2.8. Right, it's actually about to 2 decimal places, 3.36. Right. So similarly, but in fact, we compare this to negative 3.07 and 3.36 in terms of which one is further from the mean. This one is actually further from the mean. And since this is going to be a symmetric distribution, we expect the probability to actually be less than this. That's one thing we'll check. Okay. So what we're doing is draw a couple pictures again. So going from the original distribution, which looks like this, once again, excuse my drawing there, where our mean is 68.6, and we want to find way over here at 78, okay, this small bit of area. We're converting this to the standard normal distribution, okay, where this is 0, and now the z-score that corresponds to this is 3.36. And these areas, tiny areas, are the same, so we want to find this area. And so what this tells us is the probability, once again, that x is greater than 78 is the same as find the probability that z is greater than 3.36. Since these are the same pictures, just scaled differently. Now, as we learned from Excel or a table, it gives you the area to the left, not the area to the right. So another way to do this then is then to find that this is going to be 1, using the idea of a complement, 1 minus the probability that z is less than this. Okay. That would give you this area, because basically we're just in this cutoff value here of 3.36. We find the area that's left to the left of this, then subtract that from 1, they'll give us this tiny bit of area to the right. And now the way we do this then, once again in Excel, is going to be 1 minus norm.s.dist of 3.36 and the word true. In other words, this tells us the area to the left of 3.36, and 1 minus that gives us a tiny area to the right. So let's do that in Excel. Put a little space. So 1 minus, then type in NOR. And also remember, anytime you want to calculate something in Excel, you have to start with equals to use the functions. So 1 minus, then NOR. So choose this one. Then type 3.36 and then the word true and 0.00039. Or as a percent, it's going to be 0.039%. So, and what's going to be, as we said, if we pair these z-scores, the previous problem, the z-score for this one for a male that's less than 5 feet tall was negative 3.07. For a male that's greater than 6'6", it's 3.36. So we expected that the probability of finding someone taller than 6 feet 6 inches is actually smaller than probably finding someone less than 5 feet tall, because in this case we're further from the mean, further from 0, and that's what we found. Compare this 0.039% to 0.107%, it is less. Okay, now let's take a look at the next example. This one, and probably need a little more space here as well. It says, what's the probability that a man selected at random will be between 5 and 6 feet tall? So in terms of a picture, first off, our probability is that our x is between 5 and 6. Now, in terms of a picture, let's draw this first, then we'll do the z-scores. In terms of the picture, we have this. And here is 68.6. That's our mean. Okay. Now, 5 and 6 feet tall, in terms of inches, so 5 feet tall is 60 inches. And then 6 feet tall is 72. Okay. So if we put both those in, here's 72, and here is 60. And so basically, we want to find this area between both of those values. Okay. Now, let's convert both those to z-scores. All right, so for x equals 60, then I believe you've already done that one. So let's use what we've already done, because that was our first question. Okay, right. Probably the one is between less than 60 inches tall, and we already did that. It's negative 3.07, so we'll use what we've already done. And now for the other one, so for x equals 72, let's do that one. So z is going to be 72 minus the mean of 68.6 divided by 2.8. That, to do 2 decimal places, is going to be 1.21. Okay, so now see a little space in terms of a z distribution. So what we're going to show here is the same picture then in terms of z's. And so this is going to be, once again, to get the idea from the drawing, it should be exactly the same picture. Here's 0. And then for 60, it was negative 3.07. And for 72, it was 1.21. So once again, we want to find that same area there. Okay. Now, so once again, the probability that x is between 60 and 72 inches is the same as the probability that z is between negative 3.07 and 1.21. Now, if you see my previous video, we saw to do this. The table doesn't give us this, but if we subtract, remember what the table or Excel gives us, the area to the left. So if we subtract the area to the left of this one, take this and subtract the area to the left of 3.07, that will give us what's in between. So this is going to be equal to the probability that z is less than 1.21 minus the probability that z is less than negative 3.07. And in Excel, we can do this directly. There's 2 of these, so we'll do our same function, norm.s.dist, 1.21 and true, then minus the same thing for negative 3.07. All right, let's do that in Excel. Okay, let's put a little space, so equals, so NORM. Okay, so 1.21, then true, then minus, then once again type in NORM. So negative 3.07, once again, the word true. Okay, double check, make sure that's right, and hit enter. And that gives us about 80.88579. Percent, that's going to be approximately 88.579%. Almost 90% of, but 88, almost 89, almost 90% of men, based on this normal distribution, should be between 5 feet tall and 6 feet tall. That means that about 10%, about 11% of men approximately are beyond those, or either less than 5 feet tall or greater than 6 feet tall. Okay, next let's take a look at one that's kind of an interesting application. So if you remember much about the space program, oops, hang on, I didn't need to do that, so I actually need to go. Okay, let me put that back. So if you remember much about the U.S. space program, the Mercury program was the first program in the U.S. to send a person into space. And so in the Mercury astronaut program, basically they put the small capsule for one person on top of basically it was a missile, and sent the person into, the first one's even just wasn't even completely orbit. It's kind of a low, kind of what's called a parabolic trajectory. So it went up and came in like a parabola shape in the sky, and then the future ones are actually sent them into orbit. But basically, it's a very small capsule. So they had restrictions about how large a person they could be. One of the restrictions was all the pilots had to be less than 5 feet 11 inches tall, basically be able to fit in the capsule. And there were, of course, other weight restrictions, things like that as well. But basically, that was one of the restrictions. So let's take a look at men. So what percent of men currently would be too tall to fit in the Mercury capsule? So this is the same as asking what's the probability that an average man drawn at random would be too tall to fit in the Mercury capsule. They would either way as a probability or as a fraction, percentage. Okay. Now, let's think about this. So basically, so let's convert 5 feet 11 inches. So that's going to be, in terms of just simply inches, that's going to be 71 inches. Okay. So I want to find the probability that X is greater than 71 inches tall. Okay, so now I'll do exactly the same thing we've been doing. And so I'm just going to do the picture first, the regular picture. So this is our normal distribution. This is our mean of 68.6. I'm talking men currently, not men from that era, but men currently. And then 71 is going to be over here. Okay, so we want to find this area to the right. The men are going to be taller than 71 inches, taller than 5 feet 11 inches tall. Okay. So let's convert that to a z-score. So then z will be 71 minus 68.6 divided by 2.8, standard deviation. Just going to round that to 2 decimal places. And this time we get for a z-score, 2 decimal places, about 0.86. Okay, so now if we look at our z distribution, the same picture. Imagine this should be exactly the same picture. Here's our mean of 0, converted to 0. And now 71 corresponds to 0.86. And so we're looking at this area right here. Okay, now we've learned how to do that. And so the probability that X is greater than 71 is the same as the probability that Z is greater than 0.86. And we learned that, of course, Excel or tables don't give us that. So we need to subtract this from 1 to find the area. So 1 minus area to the left of that. So this is going to be 1 minus the probability that Z is less than 0.86. And in Excel, this will be 1 minus that same function, norm.s.dist, 0.86, and then true. Let's do that. So 1 minus, just start to type it in. You can find it. Make sure you pick the right one. Then 0.86. Then the word true. And that's going to be 0.194895. Okay, so I'm going to round that off a bit. And so percentage-wise, let's see. Let's just make that about 19 point, let's call it 49%, almost 20%. Okay, so today, interesting. So with men's height today, which are probably somewhat slightly taller than they were in the early 60s when the program started. So about 20% of men today would actually be too tall to fit in the capsule. Okay, and maybe not in any exact sense they couldn't fit at all, but basically that's the height value they chose, because also not only had to fit in the height, they also had to have a helmet and things like that. So that's the height limit they had. And so basically, based on today's heights, about almost 20% of men would not be able to be a Mercury astronaut simply based on their heights. Okay, one more example. So what height defines a 95th percentile height percentile? Also, how do we convert from a z-score to a height? Okay, now once again, if you've seen my previous video on this, on the standard normal distribution, we know how to find a z-score. So let's draw a picture of what this is. So remember, 95th percentile okay, means that it means that 95% of all values are at or below that value. Okay, so we draw a picture. And once again, we're assuming we talk about normal distribution. We're still talking about the height distribution. So here's our mean of 68.6. And then somewhere over here, okay, is this particular X value, height value. We don't know what it is. Basically, oops, actually, I don't need those, don't need those crosshatch values. I just need this. So let's see if I can redraw that. Okay. Basically, this cutoff right here. So this is 95% of your data is below here. And then this little bit right here is 5%. Or in terms of decimals, this is 0.95, this is 0.05. So we need to find this X value that's a cutoff. Okay. Now, first, we're going to do this. Use the Z distribution. Okay, so let's draw the same picture in terms of Z's. So here's 0, and then here is the same Z, same position. But so here, once again, this is 95%, and this then is 5%. Okay, so it's the same picture. So first, we need to find the Z that gives us 95%. Essentially, that's the 95th percentile. Then convert that back to our height data. Okay, so let's find this Z. And you've seen that before. You've seen my previous video before in the standard normal distribution. We know how to do that as well. Okay, and there's, in fact, an Excel function for that. So in Excel, the function looks like this. So it's norm.s.inv. Since you're inverse, what it does, it takes a probability and gives us back a z-score. And so we're going to put in the probability, okay, and also gives us what's to the right. Again, so 95% gives us the value to the right. Okay. Also, this is an S. So we're going to type this in, and that will give us the z-score. So let's do that. Go back to Excel. Equals. So just type in NOR and we'll look for it. So right here, make sure it has the S. Okay. Then I'll ask for the probability. So the probability to the left, which is 0.95. And our z-score is 1.644854. Basically 1.64 was approximately 1.64. We'll just round it off. So this is approximately 1.64. Okay, good. That tells us then what z-score will then give us is the 95th percentile. Now, but we're not quite done. What we need to do then is convert this to an X value. No, I'm almost out of space. I want to try to see if I can stay on this same page. What we're going to do then is basically look at our if we look at our z-score formula, let's go back over here. This is our z-score formula. It turns out if you solve this for X, what you'll get is, I'll just go ahead and give you what it is. So it's going to be X is equal to mu plus sigma times Z. Okay, so actually, if you solve this for X, Okay, so multiply both sides by sigma, then add mu to both sides, you get this. And so if we do that, that's going to be 68.6 plus sigma, which is 2.8 times z, which is 1.64. Let's do that in the calculator. So 2.8 times 1.64, then plus 68.6. This is equal to 73.2 inches, rounded off. And in terms of height, that's basically approximately 6 feet and about a little over 1 inches tall. Okay, and this is the 95th percentile. That all. So basically, once again, then what that means is that 95% of men are basically 7 this height, about 6 feet 1 inches or shorter. Okay, and what that means also, 5% of men, then the other way, are taller than that. Okay, that's what the 95th percentile means. All right, so basically, so what we did then was we first went from a z-score or a z value. We found the z that went with that probability. Then we converted that from a z-score backwards using this formula, which you can get by just solving your z-score formula for x. So what we learned today then are basically how to use some applications of what we learned in the previous video on the standard normal distribution, and how to use the standard normal distribution, probability distribution, to solve examples for applications. Thank you. Have a good day.